Integration by parts is used when you don't have substitution as an option. You notice here we do have u times dv, which is strange. If it was u times du, that would just be substitution. That meant u's derivative was in there, right? That's what u du means. This is u dv, so it's basically saying, yeah, you can pick something to be u, but then its derivative isn't going to be there because the derivative of v is going to be there, which is definitely a different variable, right? And so our job is to figure out what is u, what is dv. Once we figure that out and we're able to substitute it, basically this is what we have to do to find the antiderivative. Once again, this is two things kind of multiplied together, and sometimes you're going to choose wrong. And you're going to have to stop, cross it off, say, okay, that didn't work, let's try it the other way. The biggest thing that I had you make a note of is that in integration by parts, you have to substitute for everything. Okay? It's not like substitution where you can leave a square hanging out there, you can leave e in there, or you can leave sign just hanging around. No, every single thing has to be in the substitution. So on this problem, if we were to try substitution, we would probably, and don't necessarily write this down, but we would choose u to be x, right? Because we would like it to say e to the u. Agreed with that? Okay. If we do that, then du is 1 dx. So the funny thing is I can actually rewrite this one because I know what x is. X is u. The only problem is if I rewrite it, all I've done with my substitution is I've changed the variable, which basically got me nowhere, right? And so we know now that, you know, substitution is probably not going to work. And so we would have to come up with some other way of figuring that out. All right. Now, I know the other day when we talked about this, this is where somebody had a very good discovery, I believe. So we'll erase that. And here's how I set up integration by parts. You don't have to follow my way, but it kind of helps you out a little bit. So something in here has to be u, and basically everything else will be dv. Okay? So we know we're going to have a u, and we know we have to have a dv. I normally write it over here, because I told you everything has to be substituted for. Not just this or that, everything. Now, if you look at the rule, though, and here's how you want to start looking at this math as you do stuff. If you look at the rule there, I need a u. Well, I will have a u, right? I also need a v, though. Well, where's v going to come from? This is the observation that somebody kind of came up with before, yeah. Very good. It's the antiderivative of dv, and so what I'm going to do, I'm going to put that right here. So I have to basically take the antiderivative of dv, and I will get v. Like I told the class the other day, I don't know why they chose u's and v's, because sometimes they look alike. So it's kind of strange that they chose those, but we'll go with it. Then you look over here, oh, there's v again, and then here's du. Well, where am I going to get du from? Well, the derivative of u, right? So I will be able to get everything I need, okay, by doing this. So, and this is a v over here. See, even mine kind of looks like a u. There we go. So here's where you just have to choose and hope things work out, okay? So everything has to be substituted for. So on this side over here, we're taking a derivative, correct? On this side, we're taking an antiderivative. A lot of times what I do as my first choice is I choose, well, what do you think? Is derivative, taking a derivative of something easier normally, or is it antiderivative that's easier? Derivative's easier, right? So in other words, then antiderivative is harder. So what I would do is in dv, I would put something that's pretty easy to take the antiderivative of, just for my first try, to see if that would work out for me. So what of these things here, we've got an x and we've got an e to the x. The dx we're going to tag on there as well anyways. So should we put x over there or e to the x over there? What do you think? Well, what's pretty easy to take the antiderivative of? Well, both of them in this case, but I would say e to the x is very easy to take the antiderivative because it's e to the x. It is its own derivative and antiderivative, right? So that's something you would try. Okay, great. So e to the x dx is going to go over there. Well, remember I told you everything has to be in these two spots. Right? You have to replace everything in these two spots. You don't have to put a box around it. I'm just highlighting it. So in case somebody's listening to the recording, they know where I was pointing with my marker, which they can't see, right? So u has to be what then? If it has to, you have to get everything, right? I have to get the x yet, that one. So is that substituted for? Yes. This substituted for? Yes. All right. So everything has been everything's been substituted for. So now we got to go get these things. Now remember, to get du and v, should I be looking back up at the original to find out what they are? No, these are separate problems down here. Just do them, okay? So here's u is x, so du is 1 dx, right? Because remember, it really be du over dx, we moved it up. Same thing here, this would really be dv over dx, we just kind of moved it up, right? And so really to do this, we would actually move it down to take the antiderivative of both sides. But we already know that the antiderivative of e to the x is e to the x. Okay, so we have the setup. At this point, and you're going to get really good at looking ahead and seeing if this is going to work out. Our main goal is to get to something I actually can take the antiderivative of. So really my main goal is to get something in there that I can take the antiderivative of without something that's difficult. I want that v du, if that could be something that's easy, that'll help out. I always use this setup because now I kind of don't have to remember this as much, because I basically say it takes u times v. So I just take those two times each other, right? That diagonal, which is x times e to the x. You notice up here that it's no longer in an antiderivative sign, right? So that's part of your answer, but it's no longer in an integral, okay? And then it does say minus, right, in the rule, right? So minus the antiderivative of v du, which is those times each other, right? So that's how I always do it this way. Then it's across and then like this, right? So it's easy to remember that pattern. And in there we have what? E to the x dx. So does it appear as though we made a wise choice of our u and our dv? Did we get to something here that's very easy to take the antiderivative? Well, yeah, we just took it earlier, right? And so your final answer is, well, this is already part of the answer, so I don't really have to do anything there. This antiderivative is, again, itself. And then please don't forget something very important, because this is this definite or indefinite? Indefinite, very good. So plus some constant. Again, the reason is if I take the derivative of this, in any constant there, if I take the derivative, I will actually get back to that. And that's always how you can check these if you really want to. Okay? And then I believe we talked the other day about how the book might write that answer. Okay? That's probably not what they're going to have written down. They're probably going to have that, right? Okay, so get used to being able to manipulate your answers a little bit, especially because maybe the back of the book you might use a lot at the next level, and oh yeah, that's the same thing, we're good, right? Okay. But once again, remember, that's why you never want a multiple choice calculus test. Any questions on that one? Okay. Well, here's another one. Again, we could try substitution. But then what are you going to make u? What's du? You know, I could try u being x squared, then du is 2x, but then I can't really get that. I'm not going to put du in a natural log, right? You're not going to try that. All right, well, it's not looking like substitution is going to work, so let's give it a shot. Here's yesterday, or not yesterday, a couple days ago, when I said, well, x squared we could take the derivative of or the antiderivative of, right? But when we do take the antiderivative, it is going to get x to the third over 3, right? So that might not be good, right? But the harder part is natural log of x. We can take the derivative of that, but what about the antiderivative of that? Yeah, you don't know the antiderivative of that yet. It's on a worksheet you have in your possession right now, okay? But you don't know the antiderivative yet. So putting that in dv is probably a really bad choice. So let's put natural log of x over here. And let's put x squared dx over here. And you know what? It might be wrong. But we're going to give it a shot and see what happens. So now we need du and v. Now, one of your classmates mentioned the other day that for natural log of x, we'd have to do that 1 over log base this and all that big long formula, right? And then I showed him a way to do that. If it is a natural log, there is a quicker way. So let's say if it's natural log of, how should I write it? Yeah, we'll say u is really just u prime over u. Okay, it reduces down to that because you do log base e at the bottom and natural log of log base e, and it just kind of cancels out. So if this is u, this is basically, if you look at the formula, that's what I'm taking the natural log of. So I got to take the derivative of that over itself. Well, what's the derivative of x? 1 over itself, x. Okay? So the derivative is 1 over x. So what's v then? We already talked about it quickly. What's v? X to the third over 3. Now, here's where sometimes you might want to look ahead a little bit, maybe not. But you notice I set it up the same way, right? So you got to take u times v. That basically got out. Ooh, that's a good one. So that's u times v, right? That's out. Don't have to worry about it. Minus the integral. Well, now, hopefully, is this going to work out for us? Is that something, once I put that in there, is that something I can take the antiderivative of without a whole lot of trouble? Well, it's x to the second over 3, right? You see that? How it would simplify to that? Or I would probably write it as 1/3 out here, and then x to the second. Is everybody clear where the 1/3 came from, why I put it out front? I just like to do that. I don't like to put it inside. And x to the third over x becomes x squared. Well, it does. That's something that we can deal with quite easily, actually. Okay. So here, this already, whoa, and I almost wrote squared. That wouldn't work out so good. 3 natural log of x minus, well, if you take the antiderivative of x squared, that's x to the third over 3, right? Well, times a 1/3 is x to the third over what? 9. And don't forget, because this is, once again, indefinite plus a constant. And here's where we actually had a little debate the other day as to what to take out, because there is something in common. And I was kind of almost, well, to be honest, kind of proved wrong because somebody suggested something different from mine, and I liked their answer better. Okay. Yeah, they suggested x to the third over 3. I suggested x to the third over 9, but x to the third over 3 ended up being a better answer. So what they ended up doing is doing that. At least once it looked better. Let's put it that way. So this is x to the third over 3, so there's a natural log of x here. And then a minus. You could write it 1/3, yep. And then plus a constant. Because again, if you're going to set this equal to something, I'd rather set, you know, these two pieces equal to something instead of what we had doing it the other way. It's equivalent, but I like, yeah, that way is fine. Again, are you going to be able to see, oh yeah, those are the same? That's going to be important. Okay. Any questions on integration by parts so far? Yep. At least one more, right? And here's the one that I almost forgot why I put it on the notes the other day. And then I remembered why I put it on the notes. I should leave myself notes to remind myself of why I did it. All right. You don't forget to try substitution. You never know if it might work. So here we could try making u 4x, right? Then du is 4, but then I'm still kind of missing that x in there, right? So this isn't going to get any better with substitution. Try it, but you're not really going to get anywhere. Well, that means we have one other option, and that's integration by parts. So we have to substitute everything. What do you want to try? Just to keep it in mind, I will let you go down the wrong path. X for what? Okay. And then dv is what? Remember, you have to substitute everything. So this is your choice. Any particular reason for your choice? Just felt like it?
Yep.
All right, let's do it. No reason, we're just going with it. All right. So du.
1dx.
1 dx. Let's face it, that's not a terrible thing to have over here. Because where's this du going to end up? It's going to end up in that integral, right?
Yep.
So that's not a terrible place for something like this, right? It all depends on what v ends up being. And v, this is the actual reason that I put this problem on here. What is the antiderivative of e to the 4x? You have to be careful. You just put the 4x out front? No, you can't do that. So in other words, that's what I'm trying to solve, correct? Whoops, almost. That was the problem. And this is why this one's on here. And you have to do this one via substitution. So inside integration by parts is substitution. Okay. And then somebody in the class said, well, how am I going to keep all these u's straight? right? And that's a great question, I thought. And I said, well, some people go, this is U sub 1, this is U sub 2, and they kind of do it that way so that they can keep them straight. Or just try and keep your work very organized. You know, maybe make an arrow from DV saying, okay, here's my work for that. U is going to be 4x. Because remember, this is substitution, so I don't have to substitute for everything anymore. So du is 4 dx, but do you have the 4? Nope, so you divide by 4, right? And so really I've got 1/4 du is dx. Sorry, I didn't leave myself a whole lot of room here. So as I rewrite it, it's 1/4 du and e to the u, right? Now why do we always go for e to the u? The antiderivative is e to the u. That's why we do that one. And so 1/4 e to the u. We could put plus a constant, but that's going to come later anyways. And so, yeah, you put 4x back in, so it's 1/4 e to the 4x. Are we in agreement with how I got to what v was? Well, now we're going to find out if our choice was wise or not. Maybe it was, maybe it wasn't. Like I said, I will let you go down the wrong path, because that's how you're going to learn what to pick where. So our first part is this. This gets out, so 1/4. Yeah, I'd probably put the x next. Ooh, that's a good one. You can't beat that one. E to the 4x. That got out, and then the other part is this. So minus, right? It's always minus in there. I'm going to put the 1/4 out front again. You do not have to do that. If you're more comfortable leaving it inside the integral, that's fine. And then basically e to the 4x dx. What do you think? Did we make a good choice? Somebody said yes. Why is that a good choice then? Yeah, didn't we already just do e to the 4x? So we already know the answer to that, right? There just happens to be that 1/4 out front that we kind of have to deal with, right? So yeah, I would say this was a very good choice. And then again, it is very possible that you'll get to this step and be like, oh boy, this is not going well. Minus. So this itself is just that, right? And so can everybody see the 1/16 that would be out front? And now you have to be very careful to not forget this is indefinite. And again, they would probably factor some stuff out. Without a doubt, they would factor out the e to the 4x. And probably 1/4 as well. And so it would be x minus 1/4. It's a constant. Yep. Oh, that's a really bad 4. Okay, that is pretty much integration by parts. And here's, I believe, where some students the other day asked some questions like, you know, is that about as hard as they're going to be? Because notice it was substitution inside integration by parts, right? As you learned probably on number 1 on that worksheet, you can have integration by parts inside of integration by parts. And, well, possibly inside of that. And then there can be times where I give you 2 functions, because realize these are 2 functions multiplied together, right? I could give you 2 functions that, because notice here, the choice was to put x here because a lot of us would probably choose that because then it goes away, right, in du. But what if I put 2 functions? Because let's face it, e to the 4x, no matter where I put it, it's not going away, right? What if I put another function in there that won't go away, like sine? It'll just flip to sine, cosine, right? It'll just keep. Well, then we have some slight problems. And that's going to be day 3 as to what do you do when I give you stuff that neither one of them goes away. It would seem like it would go on indefinitely. And it could, but you just have to notice when to stop, because it can be solved. You just have to be very observant and say, well, wait a minute, I think I've got this from now. So hopefully that helps, and now the recording is done. So, any other questions? Oop, I don't need that.